All right, let's look at another example of the ambiguous case of the law of sines. So this time, notice again, we have B as the angle and the opposite pairing, and C is the third side. So it's not A and B this time, like we see in the general text and notes. So you can label these angles however you want to in these sides, but there's little b opposite big B. So this is a 40-degree angle. Little b on the opposite side is 5 units. Okay, this is angle C, so that means this is little c, this is 6 units long. So that means this is angle A and this is side length A. So again, you don't have to have this to scale, it's just a sketch to help you get things set up. So the first thing we check is the opposite side, which is little b. Is it longer than the other side length we're given? So since 5 is less than 6, we know we don't have the situation where it's just a single triangle. Okay? It could be if it's a right triangle, but as of right now, we don't have a single triangle. So the next thing that we compute is h, and h is always the side you're given that's not opposite the angle. So that's the 6 here, times the sine of the angle that you are given, which is 40. Right, so 6 times the sine of 40 is 3.86 roughly. And what we see here is B is larger than H, but it is not larger than C. So H is less than B, and B is less than C. When that's the case, that means we have 2 triangles possible. Right, one is going to be when this angle C over here is an acute angle, and the other is going to be the possibility if it were obtuse. So if you think we got this side length here, so there's the 40-degree angle. If this angle right here is less than 90, we're going to get one triangle. But we also could get one, because we're not given this angle. We could also have one like this, where this is still 6 units long. This is 6 units long. This is still 40 degrees. But now this distance down here, which again we're not given length A either, is significantly shorter. And now this angle is an obtuse angle, and that could also produce something that has that property. So we get an obtuse angle and we get an acute angle for this angle C. So we're going to select 2 triangles are possible because B is not bigger than C, but B is larger than C sine B. All right, let's set it up to solve for angle C. So the way it works is the sine of angle C divided by this 6 is equal to the sine of 40 divided by the side opposites of 5. So we get that the sine of C by itself is equal to 6/5. I always just put the numbers together. And multiplying this over, the 6 would go up top, times the sine of 40. And then angle C then is the inverse sine. So I type it all in there. Inverse sine of 6/5 sine of 40. I get 50.47 degrees. So there's angle C. So there's one possibility, 50.47 degrees. In that case, angle A, I could from the 180 rule, 180 minus 40 that was given, minus the angle we just found, 50.47, we get 89.53 for angle A. All right, and now we just set up the law of sines to find the only thing we don't know yet, which is side length A down here. So A over the sine of 89.53 is equal to the original pairing I was given that was an angle and its opposite side was the 5 and the sine of 40. All right, so solving for A, I get that, and then just typing into my calculator. So there is my approximation for side A, 7.78. All right, now that I'm going to label them A1, C1 and A1 because that's the first possibility for these angles. By the way, these things are labeled wrong down here. That should be C1, A1, and little a1. And then this should be C2, little a2, or big A2 and little a2. Now what I have to do is reset where I got this angle. Like I go back to the very first angle I saw for. And the other possibility for C is 180 minus this, 180 minus 50.47. It could have been acute, so the 50.47 is the acute version, but it also could have been obtuse, 129.53. And then we do the exact same work to find the other angles. So if that's C2, then A2 would be 180 minus the 40 again, and then minus this 129.53. All right, which is 10.47 degrees, a tiny little angle for A2. All right, and then finally, how we found little a is how we're going to find little a again. It's that opposite pairing, the 5 and the sine 40, but now instead of this being an 89.53 down here, it's this 10.47. So this ends up being just 1.41 for the second one. All right, so that's the key when we have two triangles, is one's going to be acute, one is going to be obtuse, and the obtuse, well, this one's almost obtuse, right? So it's not guaranteed that they're both going to be, like one's going to be acute, one's going to be obtuse. One of the angles you solve for will be acute in one version, and it will be obtuse in the other. Okay, but the other angle, the third angle, it could be, when this one's acute, the third angle could be obtuse here. Right? But when this one is obtuse, when we do the 180 minus the acute version of this angle, then this one now is guaranteed to be acute, because you can't have more than one obtuse angle. But it all comes down to that second thing that you saw, that first thing you saw for the second angle that you find in this SSA case, where when you have two triangles, one is going to be what you get when you just use the inverse sign to solve it, what we did here. The other one is going to be 180 minus that. And then the work from there is the same for both triangles.